Okay, today's lesson we're going to have a look at the circumference of a circle. The circumference is just another word for the perimeter of the shape, but it's a word which is used specifically for circles. So the circumference of a circle, it's just its perimeter. And before we get into the formula or a formal way of doing it, we're going to have a little exploration. So we're going to start today by a little practical exercise. So what I'd like you to do is to gather together as many different circular objects or cylinders as you can. And also what you're going to need is a little bit of string or thread or something that's bendable, and you're also going to need a ruler, which either it can be a physical ruler or you can print off a page from the internet that's got a ruler on it, but you're going to need that, some kind of ruler, tape measure, a kind of builder's measure, anything that you can measure the length of a piece of string, basically. Okay, so pause the video, gather yourself some things. I've put some examples up on the screen. You might want to get a bit of paper to draw around if it's some easier to actually draw around, or if you want to just measure the objects themselves, and that's fine. So pause the video, go and get some stuff, get yourself a ruler and some string or something that's flexible. And then come back and we'll go through this activity. Okay, so I'm assuming that you've got your things, and so what we're going to do is I'm going to show you what we need to do. I want you on a bit of paper to make a table, something like this. Okay, again, pause it if you need to. And you're going to then take one of the objects. I've taken a CD here, and we're going to measure two distances on the shape. So first of all, you're going to measure the two things that we're going to measure are the diameter, which is the widest width of the circle. It has to go right through the center of the circle. So you're going to measure that somehow. And also the other distance you're going to measure is the circumference, which is the distance all the way around the outside. Now that's the one that you need a bit of string for, because unless you've got a bendy ruler. But in most cases what you'll do is if you take a bit of string and loop it all the way around the shape, and then what you do is you get yourself a ruler, you straighten out the string, and then you measure how long that string is that went around the whole shape. Okay, so I want you to try and do that for one of your objects. So for instance, for me, I measured the circumference all the way around of this CD was 37.6 centimeters. The diameter all the way across I measured is 12. Try and do it to the nearest millimeter, so kind of one decimal place. If it's an exact number, that's fine. So I've got 37.6 centimeters all the way around, and I've got 12 centimeters across. And what I want you to do then is to divide the circumference by the diameter. In other words, how many times bigger is the circumference than the diameter? How many times bigger? Is it always the same? And if so, kind of what kind of ratio is there? So if we do 37.6 divided by 12, and I check that on my calculator, 37.6 divided by 12, I get just over 3.13. Okay, so what I'd like you to do is to basically do that for a few objects. So pause the video again. I want you to do the same for as many objects as you can, and see if you can see a pattern that emerges when we're doing the circumference divided by the diameter. Okay, so pause the video and you do this. Okay, so a few other examples that I've got are, I had an object that was 19 centimeters in circumference and 6 centimeters in diameter. I had another one that's 48.1 centimeters and 15.5 in diameter. And if you have a look at these answers, then if we divide 19 by 6, we end up with 19 divided by 6 is 3.17, if we're rounding it to 2 decimal places, and 48.1, whoa, what happened there? Oh, okay, 48.1 divided by 15.5, sorry about that, is equal to 48.1 divided by 15.5, I get 3.10. 3 point. Okay, so what we're seeing here is that the distance around the edge of a circle, the perimeter or the circumference, is just over 3 times the diameter. Okay, and that's been a known fact for a long time. Even back in the Bible, in the Old Testament and the Bible, there was instructions for lining big circular pots in the temples, and it said that it would be 3 times bigger than the diameter of it, and that's as far as people knew. It was just over 3 times, but we got a wee bit more accurate about measuring this. You'll notice it's just about 3.1 and a bit. So if you were super accurate about it, we'd actually work out that this number here should be something like that, and you may well have known about this value here, 3.1415 and so on. The number never ends. We always have to cut it if we're using it, and that the name that we give to that value has been given a special name, which is of course the word pi, which is a Greek letter of the Greek alphabet. Pi is just to represent the number, because it's easier to use a symbol rather than all the decimal places. So they called this number pi, and it represents the ratio of the circumference and the diameter. In other words, pi times the diameter multiplied by this number pi will give us the circumference. Well, that's really helpful, because that helps us to be able to work out the circumference if we know the diameter. So in other words, if we go to formalize it a little bit, we can say here that for every circle, the circumference is pi, a number just over 3 times the diameter, and we end up with this formula: C for circumference equals pi times diameter, C pi times d. And sometimes you see it and it's absolutely fine, because you may already, and this is another wee point to make, that the radius of a circle is another word that we maybe should introduce if you haven't already come across it. So the radius of a circle is from the center to any point on the edge here, and we can say that that's the radius. So if we know the radius, we could actually use the formula C equals 2 pi r, because there are 2 radius lines make up the diameter. So they're both fine formulas. I tend to use C equals pi d, but you may see and you may use C equals 2 pi r if you like. Okay. Generally, we use 3.14 as our kind of working value for pi. Okay, to 2 decimal places. Don't use any less than that. Don't use 3.1. You could use more decimal places, but that's the one we normally use. So let's quickly go on to work out some problems here. We're trying to calculate the circumference of these circles. So example A, we've got a diameter of 6 centimeters. Therefore, we can write down the formula C equals pi times d. So the circumference is, we're going to swap in for the symbol pi, 3.14, multiplied by the diameter, which is 6. And you could either work that out using a calculation, you could use a calculator. 3.14 multiplied by 6 is 18.84. 18.84. Now remember that the circumference is just effectively, it's a linear measurement. It's not a straight line, but it is a line, and it's not area or volume. So the circumference, just like any perimeter, is just centimeters or millimeters or meters. 18.84 centimeters. In B, we can say calculate the circumference, so we can use the formula C equals pi times d, which means that, watch this, you can practice using the symbol for pi. By the way, you can use straight lines down. It's like basically like a table. Okay, it's like a capital T with 2 stems. Okay, I tend to, and in most cases, the right hand line, there's a wee tick on it because it's lowercase. There's a capital pi in the Greek alphabet, just like which is much more straight, but the lowercase pi has a wee tick in it. So it's kind of fun. There's a wee chance to do a symbol maybe we don't use too often. So I digress. So we're going to use 3.14. Now watch this. If you always check the dimension you're given, this line here only goes from the middle to the edge. That's a radius. So in order to use a diameter, you just got to double it. Most of the time, You can do that mentally, but you might want to kind of check at the sides. You might even want to say, oh, look, r equals 10, so d equals 20. If it's a more complex number, you might want to do a little bit of working, but it's absolutely fine just to write in the 20. And you do that, 2 times 3.14 is 6.28, multiplied by 10 is going to be 62.8 centimetres. So there's our diameter. It's just our circumference, rather, just over 3 times the diameter. So that's how we use the formula. Just a final little note. In certain mathematics, we don't actually want an approximate answer. When we round with a calculator and using 3.14, it's not an exact value. It's absolutely fine in some mathematics to just keep your answer with a pi in it. So in this case here, calculate the exact circumference. Okay, now that's the clue here. We've got a radius of 7 millimeters. So I'm going to write down c equals pi multiplied by d. In this case here, I'm not going to swap in 3.14. I'm just going to say the diameter here. Well, diameter would be double that, which is 14. So we've got 14 here, and so we'd end up with c equals 14 pi millimeters, and that would be the exact answer. Okay. We would normally then deal with pi, we'll leave pi. So it's just a way of keeping it exact, and as in some situations that's a useful thing. And in the second one, c equals pi times d. This time, of course, the diameter is 22 meters. I don't need to double it. So I can basically write down 22 pi, and units are meters. So these are examples here where we can calculate circumference. We'll leave pi in, and what that does is it keeps the value exact. We're not introducing a rounded value of pi of 3.14. Okay, so that's the connection between diameter and circumference, how we calculate it. So you can go and practice that now.